So I'm going to talk about information extraction. When I was working on my PhD at the University of Michigan, we participated in the message understanding competitions. Okay, so this was actually, they figured out you could actually do this stuff in the message understanding competitions. It took about 10 years, 7 competitions. They did text extraction or information extraction. So when I first came to the UK in 1996, I worked at the University of Sheffield on Gate. The general architecture for text extraction. I haven't used it much since. So I'm going to do it on the fly. So as I was writing these slides, I downloaded Gate, got it up, I was going to write a text extraction system, and got about halfway through it, in about an hour of real programming. So you guys can make a text extraction system in about an hour of real programming. Or you can start a text extraction system in about an hour. Yeah? So that's what I'm going to do. I'm going to show you how to do it. I'm also going to talk about linguistics, text extraction in general, computational linguistics, lots of stuff. So first of all, I'll talk about Gate, how you get it, how you run it. I'll get a simple Gate pipeline going, a bigger Annie. A lot of stuff that Daniela talked about, I'm going to talk about too. Yeah? Quickly, because she did lots of it, so I don't have to. Right? And then I'll sort of talk a little bit about natural language and text engineering. Well, we'll do that. And then I'll go back to text extraction and Gate. I'll talk about some extra stuff. I'll talk about how you can use Gate for some other stuff. You actually can't use it for conversational systems, right? Or you could, but it's probably not a good idea. There are better things to do. And then I'll finish up. If you guys have questions anywhere in the middle, jump in. Okay? Anyone got a question? I was just hoping. Okay. Gate's the general architecture for text extraction. I'm sure Rob, Hamish, York, and others will disagree with parts of what I'm saying, but I'm going to say it anyways. So Rob Gazowskis put in a MUX entry for, I think it was MUX 4. He was finishing up his PhD. I think he was at Surrey with Gazdar, I think. And he shortly thereafter got a lecturing job at Sheffield. York Wilkes, really impressive natural language processing professor. Really, York, great papers, lots of stuff. He's 70, he's at Oxford now. Suggested that they make a tool for generating these systems, right? So if you want to make text extraction systems, York said, here's what we should do. And so they hired Hamish Cunningham, Rob, Hamish, and York, and away they went, right? I think this was in 1995, I think. In the intervening almost 2 decades, so they've been working on it for about 17, 18 years. Yeah, they've been improving the tool. It seems to be better than when I worked there. Yeah? It's component-based, so anyone can add a component. Those components are like the part-of-speech taggers, or the parsers, or gazetteers. Someone was asking about locations, so it's a gazetteer. Right? You can drop components in. Right? At some point, my doctoral thesis system, Plink, was one of those parsers. Right? So you have a natural language parsing system too. During Muck, the text extraction community figured out that you need to use machine learning to make your systems work. Right? If you want to have really good text extraction systems, you want to use machine learning. Right? So Gate also has a lot of data to do machine learning from that one can use. But if you haven't got enough data there, check out the Linguistic Data Consortium. There's a link there. Right? They've got scads of corpus. Gate's now used for a lot more than text extraction. And here you go. Here's Gate. Oh, I Googled Gate and followed the first link to gate.act.uck. Yeah, I then hit the download page and I went to the latest stable release. I chose Windows, but there are various Unix and Mac downloads. After a couple of minutes, I had Gate Developer 7.0 running. Right? It just auto-installed and it worked on my platform the first time. Right? I make no guarantees about this works for someone else, but it worked for me. And mine's just sort of a standard Windows setup. Right? That also gets you the documentation, which is also available online, and you can also load old versions, the current version, or the sources. I didn't try those. If you want to get the sources, I'm pretty sure they work. I expect help works pretty well. You can probably mail Hamish or follow the stuff. So I use start, all programs, Gate developer, from here. Start, down here, all programs, start, all programs, and of course I had Gate developer installed, so it worked. I thought about doing this here during the talk, but that seemed somewhat just too bold, so I didn't. Yeah, and it gave me a cool little window, so I ran it, and there you go. That's Gate running. Okay, so what you need to do is you have language. We have processing resources. Those are like the part-of-speech taggers, the parsers, right? We have language resources. Those are the documents you're going to process, right? You can do more complex things with data stores. And the applications, that's what you actually do. You build a text extraction system. It's an application that's composed of these components. Moving on. I then grabbed a document I had and put it into Gate by double-clicking on the language resource menu item, the 4-prong propeller. That's that thing. Yeah, that one. I could then look at the text file by double-clicking on it. Right? You get a text file. Wow. Impressive stuff. You can look at a text file. Yeah? I then added the Annie English tokenizer as a processing resource. Right? It comes with a whole bunch of prepackaged packages. Right? And I took the tokenizer. You mentioned tokenizing. So what you want to do is you want to take the document and break it up into tokens, because that's what you care about. Yeah? I then made an application by clicking on the applications menu that looks like clockwork clocks. That's that one. I called it token 1, and that's what we get. I double-clicked on token 1 and included the tokenizer by using the right arrow. In that same window, I stuck in the chocolate 1 document, and I hit this run application button, and the Gate window looks like that. So there we go. I got Gate running. I've got an application running in about, I don't know, what's that, 25 clicks? A couple types. Pretty easy, right? I just have to find a document, but it wasn't that hard. I Googled chocolate. Yeah? So there's my document. Yeah? So you get the document there. All it does is tokenize it. So I don't know if you can see here, but that's a token. It's in green, and there's a little space between it. It's a different token. It's a different color. Yeah? That's the annotator. Okay. And that's it. If you scroll down a little bit, you also actually get some stuff that's going on. I clicked on holidays. Right, so holidays is a line down here. It tells you it's a token, right? It's lowercase, the string's there, and it's 8 long. Pretty simple, right? There's one right next to it, the space token. Right? Punctuation. Actually, there's one right next to it, a colon token. The holiday token is selected. That makes sense? Yeah. What you want to do with with Gate is you want to build up an application that's going to process your documents. You don't want it to go through just this one document. You want it to go through hundreds of documents and generate stuff. Depends what you want your application to do. And these are always relatively specific things. It takes a fair amount of engineering to get it to do what you want to do. Okay? But what you want it to do is not that, when you play through and look at your tokens. What you want it to do is get that going, and then you run it, and it processes documents really quickly. And really quickly, like in seconds. So you can process 1,000 documents in a couple seconds. Something like that. Yeah, it's not particularly whiz-bang. You can take slower technology with a better parser, and it takes longer, but that's okay. It depends what you want. You want to do it all automatically. Okay, so next I wanted to get a full text extraction system running. Headline, I don't actually get a full text extraction system running in this talk. Nor have I done it since. I ran out of time. I went on holiday. That was it. I had to come back from holiday to finish the talk. And tried to follow the Annie section of the documentation. So what they've given you is a pre-packaged text extraction system. Right? So they've given you the tokens that you need. Or, I'm sorry, the processing resources that you need to do text extraction. Except for they don't really. They give you the processing things you need to do to almost do text extraction, but not quite. Right? You have to sort of play around to get the extra stuff going, and I couldn't manage to do that in the few hours I had to do this. I couldn't make it, but thought a simple pipeline would be useful. So a pipeline takes one processing application, runs it, takes the next processing application, which then uses the output from the first one, and so forth. You get a straightforward pipeline. They have other stuff too. So just in having a pipeline, you have a conditional pipeline, so that you can, depending on what's happening while you're processing, go a different way, use a different resource, right? And they also have corpus pipelines, and I get one of those going, so that you don't just run through one document, but you go through a corpus of documents, which you have to upload to the system. You have to link into the system. Okay, so I made a new pipeline. I did kind of what I did before, right? I got 3 things in it. So I've got a tokenizer, a gazetteer, and a sentence splitter. I'll actually talk about what gazetteers are, right? It's essentially proper noun lookup, yeah? Right, you have to include the document that you're going to do. There's the pipeline. It's got the names in. Gosh, they all start over here. You can move them in and out. No, that's not what happens. You have to select them from here to stick them in. Right? It's, GUI. It's easy. Right? That's not hard. Right? I really didn't spend lots of time figuring it out. Okay? It's probably a little bit harder for you because you didn't play with it 15 years ago, but it was 15 years ago when I played with it, right? So it wasn't hard for me to figure it out again. And the documentation is pretty good. It's a bit verbose, but that's good for documentation when you can read through stuff and see what's going on. I think the standard document is 600 pages long. Yeah, and you don't need this. I looked at 45 pages when I was doing stuff. Ooh, I read it, and this is what you get. So there's new annotations, right? So there's sentence annotation. I only clicked a few of them. Because if you click them all, you can't see stuff, right? So you can select the ones that you want. So the tokens are still there, right? I got a percent, so percent pops up. Yeah. You get space tokens, sentences, and stuff like that, right? And these all line out. Of course, you can scroll down and see all the tokens you want. And you can dump this stuff to XML if you're particularly interested. Okay? I had some hassles with the document annotation, so reloaded and started again. Right? So I just turned gate off, started up, and it worked fine. Right? So, you need your way of backing out, and that's what I did. The point of gate is not to get it right the first time. Set up a system that can process a lot of documents. Yeah? Once it's all done, you might want to unwind it to speed things up or improve the results. Unwind it. Take it out of gate. You got your processes, right? Individual processes which you can run however you like. Right? You might want to take them out of gate. Gate's pretty quick, but you might want to do it yourself. You might want to plug things in differently. So I had a PhD student recently, Ian Kenny, did a conversational system using gate and MyParser, right? And he just took it out of gate because it was driving him crazy in the end. Yeah? Gate with the conditional pipelines, you can go back, you can work interactively, so you can put people in the loop too. But you might want to pull it out. Gate's just middleware. Daniela had a nice slide with about 4 of these text extraction systems and a couple other ones. I mentioned another one in here for a conversational system. They're just nice middleware things to help you get going. They don't solve the world's problems. What they do is they give you lots and lots of different packages you can look at and play around with. So if you want to get au fait with these things, or even if you want to start doing some engineering, they're nice tools. Yeah, and they are pretty usable. How are we doing? I'm here till 12:30? Is that right? Yeah, okay, cool.
Yeah.
Note that pipeline is just one document. What's really needed is a way of getting meaning out of documents. Right? So it's not like that latent semantic analysis stuff where you get out a bag of words. You actually want to get the meaning out of a document. That's really, really hard. Yeah? Okay, which I think takes me... Oh, no, it doesn't take me there quite yet. So I wanted to make a corpus, so there we go. I wanted to make a corpus, so I had a new document. I took the second thing that I Googled on chocolate, I think. I had a new document and then made a corpus out of those two. So corpus is just a collection of documents. Perhaps 1, perhaps 2. I just used 2 because 1 seems a bit silly. Right? I then just follow the direction from section 3.8.3 of the documentation. Yeah, that gives me a new application. It's a corpus pipeline now, so it'll work on multiple documents. It'll run the whole pipeline on one document, and it'll run the pipeline on the next document. And then it'll just keep going and churning stuff out. Right? You can, of course, one of your pipeline things, just dump something to a file. When I worked on Gate in 96 and through, back in the 90s, right, what I did was I wrote file interfaces to have these systems that were already running read something from Gate, stuck it in a file, right, ran the program read from the file, wrote to a file, Gate came back up, read the output file. That's what I did. Right? I did it for maybe 30 different processing resources. I worked there for a year. It was my first postdoc. It was my only postdoc. Yeah, it wasn't hard. I also did some stuff with another muck. Okay, so that gives me a new... Oh, I got a new application that looks like this. I then just followed the directions from section 3.8.3 of the documentation. Did I say what I did down here? I didn't. So what I did was I went and got Annie. It was their default system, right? So you just say load Annie. It's one of the options, right? And you get this pipeline. Loaded processing resources, these. Right? So it'll reset the tokens. It tokenizes, looks through a gazetteer, splits, does part of speech tagging, does named entity recognition, and then does orthomatch or whatever that is. Okay, and it'll do it on as many documents as you want. If you wanted to just load up Gate and do this, it takes you 5 minutes.
Can I ask a question?
Shoot.
Presumably you have to have the part speech tagger before you can do named entity.
No, it's there. Oh, sorry. You want to do part of speech tagging before you do named entity recognition.
So there are constraints on the order in the pipeline.
Yeah. Well, theoretically, no. Practically, yes. So when I got Annie, right? When I got it from there, you say load Annie in section 3.8.3, you get this pipeline, right? So it comes this way. But of course, if you want to do parsing, next thing I tried to do but failed at, right? If you want to do parsing, right, you need part of speech tagging first.
Yep.
Right? But I don't actually think you need part of speech tagging before you do named entity recognition, because the words are already, you don't use those tokens, right? You're just looking for solid words. I'm looking for New York, right? I'm not looking for new noun, proper noun, York, proper noun. Yeah? So I think in this case you don't, but in general there are constraints. That's why it's pipeline.
So that pipeline came up when you
double click. Well, when I followed section 3.8.3, which said load the Annie application.
Presumably you'll save time if you run the parse before the Annie, because it'll only search the nouns at that point. So it'll save you maybe 80% processing time, rather than hunting through all the does and the verbs and stuff.
No, I doubt it. I bet you what happens with named entity recognition here is it's just doing a finite state automated search right through it. It's probably just whiz bang fast. Yeah, it depends on, and of course parsing is dog slow anyway, so you probably want to do it the other way, because parsing is so dog slow that if you can say New York is one word instead of 2 words, that speeds up things much more than the other way around. That's my guess, right? It depends on the particular algorithms and applications you're using. Yeah? No, man, York, I'm sure York has not twiddled one single bit in any of this. Yeah? I could be wrong. I'm sure he'll tell you a good story about it, though. Yeah? He might have twiddled a couple bits, but you never know. Okay. Nope, that's getting more complex, but we're still not doing text extraction. So now we've got these documents that have lots of tags about them, right, all marked up, but we're not sort of saying, this document is about that, or who eats chocolate, right? So my little goal for this whole thing was to read through documents and say, who eats what kind of chocolate, right? Pretty simple application. I'm actually pretty confident I could pop it off by the end of the week if I spent my time doing that. Yeah? Of course, it wouldn't be perfect, but let me tell you, let me be clear, right? None of them are perfect. The English tokenizer isn't perfect. When you go through a set of documents, it'll tokenize wrong. It gets most of it right, because tokenizing is pretty easy, right? Part of speech tagging gets about 97% of it right? They fail all the time. Parsing, text extraction, they fail a lot. They get it wrong. They tell you the wrong answer sometimes. They miss the right answer sometimes. They just don't give you a right answer. Okay, which takes us to microphone. 32 minutes. Linguistics. So what I've done is I gave you Gate, right? I'll do a little bit more Gate down here. Yeah, but now I want to talk about natural language processing. Okay. Who's a linguist here? Anyone? No, not surprising at all, right? Who here might put on their CV computational linguist? I can't put linguist on my CV. I could put computational linguist. You can put computational linguist on your CV. Yeah, you can't say, I am a computational linguist, but on your CV somewhere it says computational linguistics. Yeah? Anyone? No? Fair enough. Okay? Linguistics is a relatively old field, about 150 years old. It depends how you want to do these things, right? My grand supervisor, Roger Schenck, that's my supervisor's supervisor, right? Got his PhD in linguistics. Yeah? There's been an ongoing considerable advancement in linguistics. We've been making progress for 150 years. We understand more and more about how language works. We don't understand it perfectly, but we understand more and more about it. You guys can all, who's here? You guys are all cognitive scientists of some sort, right? So you can read Ray Jackendoff's book on Foundation of Language, Brain, Meaning, Grammar, and Evolution for an accessible, interesting read. Helps a lot in starting to understand how language works, how people really process language. Ray's sort of theory here is that there are different linked subsystems in the brain, right? There's one for phonemes, one for lexical analysis, one for syntax, one for semantics, separate, more general system for memory, right? And they talk to each other. It's a really nice way of looking at how language works. I'm sure it has problems with it. I'm sure that theory has flaws, but I think it's pretty advanced, works pretty well. Ray points out that there are several systems that interact. I said at the beginning of this talk that I worked on the message understanding competitions in the 90s, right? I think they started in the 80s, right? And the very first message understanding competition, Message Understanding Competition 1, ran through 5 documents, and most of the 10 submitted systems couldn't actually process one of the documents. So in 1986, the field of computational linguistics couldn't actually process documents, right? And by the end of it, most of the systems went through, read newspaper articles, and generated templates summarizing the newspaper articles, right? And they got, 40%. My own, in Mach 7, my own system that took me 1 day to develop, right, got 1% of the templates right? I got a reasonable, absolutely atrocious score. It's embarrassing, but it worked after a day's development. Okay. What they've done, what they figured out there is don't do what linguists do. Don't try to figure it out perfectly. Don't try to rationalize everything. Just do the easy things, right? They've skipped the ambiguity. Language is really ambiguous. Right? Natural language, ambiguity is all over the place, right? And they've gone for the percentages. They kludge the processes with cascaded finite state automata that can be learned, right? So you don't parse in a context-free manner. You use cascaded finite state automata. Use a regular grammar. It goes really fast. What's really nice about when they're really fast is you can make your grammar better really quickly because you got a quick turnaround on your system. The learning can be semi-automatic or automatic. In Mach 7, one of the systems that did quite well was Mach 7, 1998, 1999, so old technology. Yeah. One of the systems, Task, what they did was they went through documents that had templates in them, right? People marked them up. People off the street, people who didn't know things about computational linguistics, went through and said, this is why this document's about a rocket launch event, right? And this is how you fill in the template. They went through and they automatically learned what things were relevant for this particular domain, right? And that's what text extraction is about, right? It's about reading through documents about a specific, relatively small domain, right? And extracting them automatically. Why would you want to do that? Well, in 1997, we didn't really have the internet, right? So what they wanted to do is they wanted to go through newspaper articles and do this for intelligence. So the CIA wanted to go through and look at Central American terrorist events by reading articles from newspapers in Central America, right? And then the guy who's an expert at the DoD or wherever it is in the US, right, doesn't have to read all the documents. He just gets to read the ones that have the templates in them, ones that are interesting to him, right? And it cuts down his load, right? Can you imagine that being used for anything nowadays? Well, maybe not Central American terrorist events, though, that's relevant. They can be used for lots of things, right? What are you interested in? What are the good papers in your field? Well, do this automatically. And if you can build that up, you can get feedback from that. Okay. It's a lot to develop something to read papers, by the way. Come up with templates. Okay. So the first thing we did with Gate was tokenize. All that does is read the document and break it into words. That's hard. Don't be fooled. The machine doesn't understand the document. It's called natural language understanding. I do artificial intelligence. We're not close, right? They don't really understand the documents. They're doing really stupid things, right? Next bit is the part of speech tagging. Part of speech of the word is its type. It's a noun or a verb, right? Most, or at least a lot of words, are lexically ambiguous. Run, is that a noun or a verb? I went for a run yesterday, and I'm going to run down to the store. It's both. It's lexically ambiguous. Both categories. There's no broadly agreed tag set for English, or really any natural language. Right? The French actually have a broadly agreed set because they've got a group that actually sets it. But the rest of the world doesn't agree. They disagree amongst themselves, right? What a tagger does is go through a document and tag each word with its part of speech. Why do you want to do that? Because you want to parse it. What the parser does is it goes through, mostly, and just takes the part of speech, right? It doesn't care if the words run, or hit, or jump, or fall, right? It just bangs it away. The Brill tagger is an example of this. It gets about 98% of the words right? It's trained on a document set that's marked up, word, part of speech pairs, right? So you got a word, you got a document, right? There's a word in it, and you say which part of speech it is. Word, part of speech, right? And it goes through and learns from that. Yeah, it's a simple thing, right? You get the trained version, but it can be trained. I had a PhD student 8 years ago or 10 years ago, Vivian Orango, who's Brazilian, right? She was doing cross-linguistic information retrieval. She used GATE a little bit, and she used latent semantic analysis, which kind of fits in with the LDA stuff that you mentioned. Yeah, and they didn't have a part of speech tagger for Portuguese that was very good, so she wrote one, right? They're easy. Someone asked a question on Daniela's talk about different languages, right? Most of the resources here are for English. There are lots of resources for other languages. My point about Portuguese is the 8th most spoken language in the world. There's a part of speech tagger for it now, right? And people used it. People were calling her up and saying, can we use it? Or we found a bug in it, or we can't get it to run. And she helped them out, right? So there's part of speech tagger for Portuguese. I should also mention, someone asked a question about, in a similar vein, there's a question about Chinese. Indo-European languages are really quite similar. That pipeline will work for it. I did some work in Arabic, and it's morphologically more sophisticated, so you need different processing. In Chinese, you need different types of processing too. But that Mach 7 competition, I was looking through the documents when I was writing this last week, and they had a Chinese version of it. So in 1997, they were working with Chinese and Japanese too, right? So these things do work for other languages. Whether they work for Inuit, who knows? Because there aren't that many Inuit speakers, right? But write your own Inuit part of speech tagger if you're particularly interested in Inuit. The Brill tagger is just a simple Markov model with a couple word look ahead. It's really fast using finite state automata. It's really fast. Like on this PC, you can parse 1 million words before I go to the next slide. Yeah, it just goes, right? Which is nice if you want to parse a lot of documents. Parsing your parse tree was much better than mine. I had to do mine by hand. Parsing builds a syntax tree for sentences and, at least theoretically, a case frame structure for semantics. What you care about a sentence is not this tree, right? So here's my sentence. I saw the girl with the telescope. I use this one all the time. That's the reason behind that. What you care about is this, the case frame. So the actor is I, the object's the girl, and the instrument's the telescope. So that's what a parser does. Now you got those things. What you want your text extraction system to do is combine these across multiple sentences and come out with the information that you're interested in. That's really not that hard. My doctoral work and some more recent neural work, I do neural simulations nowadays, so real neurons, has been one-pass parsers, which is more psychologically realistic. When we read a sentence, we read it left to right? We don't sort of go back and forth. The best parsers get around 90% of attachments right, and they're really quite slow, agreeing with you. But they do other things. They're not sort of psychologically valid. They do chart parsing, stuff like that, which is cool. And if you're engineering, that's fine. Yeah? If you're trying to do what people do, that doesn't work. Is there any ambiguity with I saw the girl with the telescope? This is one of the things I'm really interested in, so I use the sentence all the time.
Either the girl had the telescope or you saw her using the telescope.
Right. So it turns out, for Brett, I did this with my doctoral thesis too. You guys catch the ambiguity there? Mm-hmm. Who's got the telescope? I saw the girl with the telescope. Or does she have it? Yeah, that's why it's ambiguous. It turns out 90% of the people, when you give it to them in the null context, say that you saw with the telescope. Right? And that's the way my frame comes out too. That's the way I generate it. Yeah, no, there you go. But you can't, it's really hard to saw with a telescope. That's the problem. Yeah? Or, of course, you could be ungrammatical. That would have a different deep structure, though. It would have a different function. Yeah, no. So the point of the ambiguity, the parse ambiguity, is that prepositional phrase would go under the noun phrase if it were, I saw the girl who was carrying the telescope. Yeah? And of course, this all depends on context. This is my point about ambiguity, right? You can have ambiguity with saw, cheeky. Yeah? Okay. Shh, what am I doing? 20 minutes. So a lot of parsers go through 2 or several. So in the muck stuff, and currently, what people do is they go through several stages of finite state automata, and they're really fast. So what you do is you go through the first time and you parse the simple noun phrases. So you get with the telescope, the girl, right? Just by itself, right? That's really quick. Then you go through and you combine those, right? And you miss some things, but that's okay because you don't need things to be perfect. The second combines the phrases and may miss things. In Annie, we haven't done parsing yet, yeah. And in fact, we don't end up doing it. I almost got there. Prologue got me in trouble. Semantics. What you really care about in the document is the semantics. Now, when you do your text extraction system, you only want to get particular semantics, right? So I only care about who's eating chocolate in my example, right? I don't care about the rest of the sentence or the rest of the document. And I don't think we really have a good handle on semantics. I don't think humanity does. I don't think we really understand what meaning is. So when you're talking about features, you're just coming up with some kludge of what language is, right? Bag of word techniques like latent semantic analysis and apparently LDA also are a nice proxy and enable the extraction of some semantics quite automatically. So you go through documents really quickly, build your little latent semantics analysis tree and say the document's about these things, or it's like this document, or it's got like these words. That works pretty well. But even simple problems like the meaning of relatively unambiguous sentences like I went to the store are open to a wide range of discussion. I'm sure I could sit around down in the pub and argue with people about what that sentence means. Problems like what is a word sense, metonymy, and metaphor, all difficult for machines, but easy for people. Right? I said, I read Mark Twain. Did I actually sort of look at Mark Twain and read the tattoos on him? No, I read a book by Mark Twain. That's metonymy. Right? People don't have any problems with that. In your program, you need to say, oh, Mark Twain is an author, so what's really meant here is that you read his book. But if you're talking about tattoos, you're reading the tattoo on his arm. Okay. That's not to mention things like default reasoning, Gricean implicatures, tone, gesture, common sense reasoning. Man, language is tough. Yeah, it's really, really hard. But you can make a pretty good guess right off the bat. Your first guess is usually right. Here's some other bits that are important. Co-reference. There are a lot of other things that can be done in Gate and other text extraction systems. And when you do them, they make your system better. Right? Co-reference involves multiple phrases referring to the same object. E.g., I went to the store and it was closed. What was closed? The store was. That's just pronominal reference resolution. But in your document, you've got lots of different ways to referring to something. So the store could be the big store, the closed store, the store I went to yesterday, it, Bob's, or 7-Eleven, right? Lots of different ways to refer to things. You need it to bind documents together, and the best co-ref results are in the 90s. Gazetteers, or gazetteers for supporters of Paul Gascoigne. Anyone get that joke? No? Okay. I actually typed it in gazetteers at first, and I sort of went through and said, oh, that's misspelled. I felt good about that. Are also really important. There are lists of properties. Paul Gascoigne was called Gaza, so if you didn't quite get that joke. As proper nouns like Santa Claus are usually relatively solid. These lists can be used to give some solidity to the text extraction. So someone had a question before about tweets and locations, right? There's some problems here, but use a gazetteer. My answer was use a gazetteer. Your answer was better. Yeah? It's a good thing I didn't answer. We can't parse well. This are, of course, extracted into the tag set. So a gazetteer going in Gate, we'll just go ahead and annotate the token and say this is, or make a new token for New York and combine the two, right? And say this is a location, or a city, or a state, or something up in New York. We can't parse well, so most text extract. We can't parse well. So when you parse a sentence, one of the best systems that are parsing a sentence get lots of it wrong. Get sort of 90% of it right. That means they get 10% of it wrong. Which means pretty much every sentence there's something wrong in it, unless it's a really short sentence. Right? So if we can't parse a single sentence, how can you do full discourse analysis? How can you read a whole document and say this document means this? Essentially building a discourse tree for the whole thing, connecting everything perfectly. That doesn't work. Yeah, if you want to work on that, doctoral theses, postdocs, papers for years, you'll have a job for life. However, things can be combined across sentences. So you don't always get it right, but you can do pretty well with it. You can do reasonably well with it. Okay, which gives us 15 minutes of precision and recall. I've said things like with a part of speech tagging, the best systems get about 98% of the words right. Simplification, because getting right is ambiguous. Right? In the case of part of speech tagging, each word gets tagged, so 98% is reasonable. But if you have a document with a template, that's it, you want it to come out of it, or 3 templates you want to come out of it, right? You want to give answers, right? And if your answers are right, you have high precision. If you get all the answers, you have high recall. It's easy to get high precision. It's easy to get high recall. It's hard to do both, right? So in text extraction and information retrieval, where they stole this from, you really care about precision and recall being combined using F measure, right? I would be happy to explain this at length. There's a really nice wiki on it. So if you wiki precision and recall, or you Google precision and recall, you get a nice wiki on it, right? I would spend more time, but I only got 14 minutes left. So I'm moving on. Okay, systems versus people. The precision and recall measurement make use of a gold standard. So some guy's gone through and said, this is the way this sentence is parsed, right? The gold standard is developed by people, and it's not perfect. People make mistakes doing these things. Moreover, not only do people make mistakes, people can't actually sit down and agree, right? So a good indicator of how perfect the standard is inter-annotator agreement. You have 2 annotators or 3 annotators, and if they all get the same thing, that means your gold standard's really good. If they get different things, that means your gold standard's not very good, or your problem is so difficult that people can't even do it with wide agreement, right? So if the F measure multiplies precision times recall, right? So it combines the 2. It's hard to get both good precision and recall. If the F measurement between annotators is roughly the same as your system's measurement, then you've done about as well as you could. So if you're doing a text extraction task and you get 47 on an F measure, that might be really good and it might be absolute rubbish, right? If your task is really easy, it could be real rubbish. If it's really hard, it might be really good, right? Go see what the inter-annotator agreement is. If the inter-annotator agreement is 52, you've done really well. If the inter-annotator agreement is 98, you're rubbish, yeah? In Mach 7, the best named entity system, named entity. So you want to go through a document and find the named entities like New York or a Boeing 707, right? And say what they are. New York's a city, or New York's a state, Boeing 707 is an aircraft, right? In Mach 7, which as a proxy of where we're at, the best system got 93, and inter-annotator agreement was 97, right? That's a pretty good system, right? For the full template, the inter-annotator score was 97, and the best score was 51 by SRA there in Washington, D.C., right? Me, just by myself, there was one for template entities, right? I got a 47. I think the best score was better than that. Inter-annotator was a lot better. And ST about 1. But I did it in a day, right? So you can build a text extraction system. In Gate is where I was doing it. Use my own parser and had to get my own little text extraction system, right? Day. I fixed the bug and I got 15%, I think. I had to do it afterwards, though. Okay. Completing the text extraction system. I can finish a TE system this afternoon. Can I finish a TE system this afternoon? I've already given it away. Unfortunately, our heroes, the Gate team, have left us without a TE system. Right? Following their lead, I'm going to try to build a complete Annie. It seems they have lots of extra resources that I've downloaded with Gate by default. I'm now looking for a parser, because what you want to do after that, next bit of the pipeline is you want to parse, and then you want to do template extraction. Okay? I see the Sept parser looks a lot like the bootstrap parser that I used from 15 years ago. I seem to need a prologue, so I download the free prologue Cafe 1 at this stage. About an hour of proper futzing in. I spent an hour and a half trying to get the prologue running. So I just gave up. Right? I'm giving up. I'm entirely confident that I can get Sept running. Right? They also had, you mentioned Stanford parser. I think it's state of the art. or up there, right? They had that too, right? Assuming I could, I then need to build some templates from the data that I have. So I'd have those frames from all the sentences, or partial frames from partial sentences, because I might not parse them perfectly, right? And if I can't parse them perfectly, I just take the information I got from what's there, right? I'd use dissent, which they provide, right? Again, in Prolog, which is the discourse interpreter for largely the same reasons I use Suspel. I worked on it 15 years ago, right? And what you do with template filling is once you're done parsing, you should have the basic semantic units. Co-reference resolution may have decorated these, so you can find out more things about an item because you know more about it because it's been referred to by several different phrases. You then need to, in a task-specific way, fill your templates, right? So now it's entirely task-specific. Parsing's relatively generic, but now if I want to build something to find out who's eating chocolate, I have to actually look through what people do when they eat chocolate. How's eating chocolate described, right? So in essence, this is where you query the knowledge you got from NLP to build your answers. If my template's about who eats chocolate, I can look for sentences like, Chris eats chocolate. That's easy, right? And what's nice about it is that happens a lot. When you're worried about people eating chocolate or people shooting rockets into space, that was the Mach 7 task, right? You find that the space shuttle was launched on December 23rd in the documents sometimes, right? And those are easy. So you pop those off. So you can get a pretty good score right off the bat with those things. Depending on the parser, these may be recorded semantically or syntactically. The system can also bridge items by guessing. For example, if you've not got a full parse of a sentence, but two items are in the same sentence, you might want to guess their relationship is enough to fill a template. So the space shuttle, which was built in 1985 in Texas, was launched. Well, you can imagine the parser failing on that relative clause, right? But if you've got a sentence that says space shuttle, which we know is a rocket from named entity extraction, right? And then later on in the sentence, was launched, you can say, hey, the shuttle was launched. You can just guess. Now, you can often be wrong that way, right? But you can often be right. The question here is, do you want to have high precision or high recall? If you want to have high recall, you guess. If you want to have high precision, you don't. You can imagine how this is easier for just named entity categorization. So if all you want to do is say this thing is a state or a rocket, that's a lot easier than filling in a full template about what rocket was launched, when was it launched, where was it launched, what was the goal of it, who launched it. Yeah? Where who ate chocolate is a much easier task, right? Probably harder than named entity recognition. Sweet. Text extraction is about getting specific answers. Consequently, the system needs specifics. Latent semantic analysis won't work, right? It's different to say Chris eats chocolate and say Chris does not eat chocolate, right? Latent semantic analysis will give you the same exact result for either of these things, right? Not actually gets pulled out of most LSA algorithms. However, there are lots of ways to say Chris eats chocolate. Ooh, look at that, chocolate, right? That was chocolate. You guys didn't even notice that was misspelled, right? But, there you go. People have no problems with that. Parser, text extraction system, has absolutely no idea what chocolocat means unless you write a system that does spelling correction. Right? I left that one in intentionally. Yeah? TE systems can get most of them, particularly as most common ways account for the most occurrences, which is a tautology. Right? However, they don't get them all. Remember, the system needs to be told the most common ways. Chris, the guy giving this talks, likes chocolate. Right? Does like mean I eat? I might like it because it just looks good. Yeah, which it does. Yeah, but you can probably guess that I eat chocolate because I like it. But if you say Chris likes blue jeans, does that mean I eat them? Probably not, right? So you need to build that into the system, right? And that task, that thing where you go through and mark stuff up, you have a person semi-automatically go through and mark documents up, is meant to find these things. That likes usually means the same thing as eats when the object is chocolate. Like it's not eats. What do you do about co-reference? It's another problem. So I'm gonna. I'm going to do one thing really quickly. Gate can be used for other things than TE. An example might be conversational systems. However, you might want to try a different bit of middleware for dialogue, for example, Ravenclaw, right? Note that this system also needs to be tailored for the domain. Ravenclaw does. That's where we are with AI. You need to build domain-specific applications. Right? If you want to do things really well, you have to put the knowledge in, right? Maybe you can use some machine learning there. Okay. And as I've only got 5 minutes left, hopefully, for that. Gate is good for prototyping. There's that line. And here's the take-home slide. I hope. Yes. 1, you can build a text extraction system in Gate. 2, it's not going to be perfect. You get diminishing returns on a particular system at some point. Right? What happens is you develop more and more and more. This is precision and recall numbers, right? P, R, right? And F measure, right? You get that. Right? So you can keep adding new things, improve your co-reference algorithm, and it'll get better and better, but then you'll work on it really hard and just get slightly better numbers. Right? And if you can work on it for the rest of your life, unless something changes technologically, you're never going to get as good as people. Right? Unless it's a really easy problem. Yeah? The smaller the domain, the better the performance. So eating chocolate, small domain, rocket events, bigger domain, document summarization, which you can do in Gate, much harder. Good thing for document summarization, just take the first paragraph. There you go. That's they used to win the document summarization task. Right? The more time you can devote to domain knowledge and system development, the better performance is. And this is important. The second one is easier. So if you use Gate to build a TE system, right, it'll be a pain in the rear. Right? But when you build the second one, it'll be a lot easier. Yeah? I expect it to be the same if you're using some other application and there's probably some other middleware and it would cross. And I didn't really sort of make this as clear as I would have liked to in this talk, but natural language processing is fun. Right? It's interesting. There are problems that we haven't solved, and I don't think we're going to solve, but we can make lots of progress on them, and it's useful. I sort of stopped doing this in 1997, 98, done a little bit of NLP since, not much, right? Which was just as the internet was taking off. So those guys in Sheffield have done really well with it. Right? It's really useful to process lots and lots of documents, which now we have freely available. I have 3 minutes left.